We're going to start solving inequalities, and it's really very easy, especially if you know how to solve equations. When you have an inequality, the difference between that and an equation is this symbol right here. Instead of being equal to, it's either a less than, greater than, less than or equal to, greater than or equal to. It also means that there's not just one answer, that there's numerous answers. So there's so many answers, we can't really list them all. In this case, we have to ask ourselves, 3 plus what is less than 9? Well, 3 plus 6 is equal to 9. So to be less than 9, x would have to be less than 6. So how many numbers are there less than 6? An infinite number of those. So we have to show the solution as a graph. We don't have a choice on that. We circle our focal point, which is 6. And then since the values are less than that, we do an arrow going to the left. Now there's a little trick to this that says if your variable's in the front, then your inequality sign points the way your arrow goes. Okay? If we are not including the 6, we leave this as an open circle here. Okay? If this had been x is less than or equal to 6, which means it also includes the number 6, we would close that in. Okay? So an open circle goes with these two symbols right here, and a closed circle goes with these two symbols right here. Okay? So now let's start to solve these. Okay? What plus 4 is equal to 7? Well, we know that that's 3. Okay? It's a little more difficult to solve sometimes when the variable's on the back side. But basically what you've got here is that x has got to be greater than 3. I always like to take this and flip it over and rewrite it as x is greater than 3. This actually says 3 is less than x, which is the same thing as x is greater than 3. When you flip this over, you'll notice that this is pointing towards the 3, so make sure here it's pointing towards the 3. Okay? And then how are we going to graph that? Well, let's put a 0 in the middle, and let's 5.3, 1, 2, 3. Let's circle that. And then since the x is in front, I'm looking for the numbers that are greater than, that's pointing to the right. I'm going to shade this in. Now go back and ask yourself, do I get to include 3 as part of the solution? No, I do not, so I leave it as an open circle. Okay? It's just like solving one-step equations. You have to get the variable by itself. You isolate the variable by using the inverse operations. And as long as you do the exact same thing to both sides, you're in great shape. So let's just do a couple, all right? So remember we talked in equations about there being a wall here? Well, that wall is still here. It's just got an inequality sign stuck in the middle of it. All right, x plus 12 is less than 20. Subtract 12 from both sides. That's going to give me x is less than 8. So we're going to maybe put our 0 over here now. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is my focal point. Put a circle there. Less than goes to the left. It does not have the or equal to, so I leave it open. Okay? This one you'll notice has a 5 subtracted from the d, so we have to do the inverse, which would be to add 5. That's going to give me d is greater than, be careful of your signs, negative 2. Put a 0 here. How about a negative 1, a negative 2? You'll notice on the number line, positive numbers are on the right, negative numbers are on the left. Let's circle this. D is greater than negative 2. It goes this way. Go back and check. Do I close this in? No, I do not. Okay? Now this is going to work with anything. It doesn't make any difference. Fractions, decimals doesn't make a bit of difference. So let's look where our n is. It's right here. Let's add 0.3 to both sides. Again, do the exact same thing to both sides. I get 1.2 is greater than or equal to n. Now again, you can graph this, but the little trick that I showed you a minute ago is saying that the arrow points the way, the inequality sign points the way the arrow is going, does not work unless the variable's in the front. So if I take this and flip it over, I'm going to get n. This is pointing towards the end, so it continues to point towards the end. 1.2. So this is 0, 1, 2, 3. I don't know exactly where 1.2 is, but I'm going to guess it's somewhere about, somewhere about in here. Okay, so there, let 1.2 be right there. So I'm going to circle that. My arrow points to the left. But since this has the or equal to, that means I'm allowed to include 0.1.2. So I'm going to go ahead and color that in. Okay, and that's the difference between those. All right, let's try this one. Threw a little fractions in there for you. So let's add 3 to both sides. That's going to give me 5 and 1/2 is greater than or equal to t. Again, my t's on the back side, so I'm going to flip it over and write it t is less than or equal to 5 and 1/2. I'll make my 0 here. 1, 2, 3, 4, 5, 6. I'm going to say that 5 1/2 is right here. I'm going to put a circle there. My arrow is going to go to the left. And then I'm going to go back and say, am I allowed to include 5 1/2 as my answer? Yes, I am. So I'm going to color that in. Now remember we said there were lots and lots of solutions to inequalities. So it would be impossible to check every single solution. So what I can check is the end point, where I'm putting that circle, that focal point, and the direction of the inequality. So for instance, if I have this equation and this is my answer, I can check to see if 6 is correct for the endpoint by putting a 6 right in here. 6 plus 9 is equal to 15. Check. All right. Then it says that the x values that I need to choose have to be less than 6. So all I need to do is pick any value less than 6. So let's pick 4 and put it in there. 4 plus 9 is less than 15. Well, 4 plus 9 is 13, which is less than 15. Check. Okay? And that's all there is.